Hello everyone. Welcome to my mini lecture. Today's lesson is the debugging of combustible gas circuits. The learning objectives are to help students understand and become familiar with the detection of gas sensors. Key and difficult teaching points: the detection of gas sensors. During the operation, please follow the principle of safe use of electricity. Before powering up the circuit, ensure that there is no short circuit, so as to avoid damaging the combustible gas detection circuit. Question 1. How to check the soldering quality of the PCB? What are the criteria? Since the combustible gas detection circuit for this task is relatively simple, with fewer than 30 solder joints, we can visually inspect the quality of the solder joints. The solder joints should be smooth, full, and shiny, without any cold solder joints or solder skips. Question 2. What checks should be performed on a soldered functional PCB before powering it up? Why is it checked? How to check it? Before powering up a soldered functional PCB, we should first check for any short circuits. Powering up a PCB with a short circuit can cause sparking. In mild cases, it can burn the skin. In severe cases, it can result in death or cause a fire. The specific checking steps are as follows. 1. Before powering up the circuit, use a multimeter to check for short circuits. Set the multimeter to the ohms range times 1000 or times 100. Connect the red probe to the power supply terminal J1 of the combustible gas detection circuit, and the black probe to terminal GND of the circuit, and then observe whether the multimeter's pointer points to 0. 2. If the pointer points to infinity, it indicates that there is no short circuit. 3. If the pointer points to 0, it indicates that there is a short circuit, which should be found out. Question 3. How to locate the fault in the circuit? 1. Carefully inspect the circuit's solder joints again to check if any solder bridges are connecting the joints. 2. If no solder bridges are found, use the electric soldering iron to disconnect the IC operational amplifier LM358 and the gas sensor from the PCB. Dividing the circuit into two sections for further inspection. 3. Use the ohmmeter function of the multimeter to measure the components R1, R2, R3, R4, R5, and D1 on the PCB. If the resistance values are not 0, it indicates that these components are not damaged. Then, measure whether the gas sensor MQ2 is conductive between pins 1 to 3 and pins 4 to 6. and whether there is some resistance between pins 2 to 5 until the faulty component is identified. 4. If these components are all functioning normally, replace the LM358 chip with another of the same model on the PCB. Use the ohm meter function of the multimeter to measure the resistance across the filter capacitor C1 to see whether the resistance is 0. The above steps can find the faulty component. After powering on, place the module into a container with a certain concentration of combustible gas and check if the alarm light turns on. Through the debugging of combustible gas detection circuits, we have improved our understanding of the gas sensor MQ2. Finally, please briefly describe the process of the combustible gas detection circuit and the operating principle of the gas sensor MQ2. That's the end of this lesson. Thank you for watching.